Welcome. In this video, we'll take a closer look at two essential concepts in data and data analysis, namely, dimensions and measures, and the ways in which they are used in Legoz and Insights. We will discuss the definition and role of dimensions and measures, provide you with some examples, and give you an overview of their usage. First, let's talk about dimensions. Dimensions provide the context and structure needed to analyze and understand data, and a sound understanding of how they work is a fundamental requirement for anyone involved in data-driven decision-making. A dimension can be defined as a data element that categorizes facts and measures to enable users to answer business questions. The role of dimensions is to describe how data is organized and categorized, providing the perspective for analyzing quantitative measures. Let's discuss some common dimensions in a sales dataset. Time datasets may include year, quarter, month, and day. Location datasets may include country, state, and city. Product datasets cover product ID, product category, and brand, while customer datasets may include customer ID, customer segment, and age group. In Legoz, dimensions are used to group and filter data, while in Insights, they allow for the slicing and dicing of data to explore different perspectives. Dimensions have some unique attributes. These include the fact that they often have hierarchical relationships, for example, year, quarter, month, and day. They also facilitate different levels of granularity. For example, a date dimension can be detailed down to a day or aggregated up to a year. In databases, dimensions are stored in dimension tables that are linked to fact tables containing measurable data. Some contextual examples of measures include: in retail, product categories, store locations, and time periods. In finance, account types, transaction types, and time periods. In healthcare, patient demographics, treatment types, and time periods. Now let's turn our attention to measures. Measures can be used for analysis and are numerical values that provide information about the performance, volume, or quantity of something. A measure is defined as a quantitative value representing a specific metric or key performance indicator. For example, product category, or customer region in a sales dataset. A measure's role is to provide data points that can be aggregated, summarized, and analyzed to provide insights and inform decision-making. Some examples of common measures in various datasets include sales, total sales amount and quantity sold; finance, revenue, expenses and profit; operations, units produced, delivery time, and inventory levels; healthcare, number of patients, treatment costs, and recovery rates. In its simplest form, data aggregation is the process of compiling typically large amounts of information from a given database and organizing it into a more consumable and comprehensive medium. Measures can be aggregated in several ways: sum, total sales amount over a period; average sales per transaction; count, number of orders placed; min or max, minimum or maximum value of a measure. Measures are used for reports and dashboard displays, to track performance, and are used to create visualizations like charts and graphs. Measures often represent key performance indicators for organizations to track and gauge success. Measures can be directly collected from transactions, or derived from other measures. Calculated fields such as profit, which is revenue minus expenses, or growth rate, the current period sales minus the previous period sales divided by the previous period sales, are examples of derived measures. Measures can be analyzed at diverse levels of granularity, depending on the dimensions that have been specified, such as viewing total sales by day, month, quarter, or year. Some contextual examples of measures are retail, total revenue, average transaction value, and units sold. Finance, net income, operating expenses, and return on investment. Healthcare, average length of stay, cost per patient, and number of treatments. When assembling an aggregated data object in Legos, users should ensure that the attributes used for aggregation are designated as measures on the data object, and that the aggregation option is activated on the data object configuration screen. In conclusion, understanding dimensions is crucial for designing effective data models, performing comprehensive data analysis, and creating insightful reports and dashboards. While measures provide the quantitative basis for evaluating performance, identifying trends, and making informed decisions. When used together, dimensions and measures allow you to slice and dice data for deeper insights, ultimately driving better business outcomes. Thank you for watching. Catch you in the next one.